Hey everyone, welcome to the Swift Arcade. I'm your host, Jonathan Rasmussen. In this episode, we're going to continue our journey building the Starbucks application. Now we're going to start by adding a new screen here called History. Now this may not look like much, but there's a lot going on into building this view. We have to figure out how to parse JSON. We're going to be making HTTP RESTful GET request. We're going to look at something called a view model, which takes data and very nicely puts it into a table view. So if you're interested in seeing how we can do that to build a new view for our Starbucks app, come on in and I'll show you how all of that stuff works. Okay, let's start by seeing how we can break this down into a series of smaller problems and get a feel for the overall architecture of what we're working with here. This is all going to start for us with an HTTP request to a backend AWS instance, and what we're going to be getting is JSON. So the first thing we're going to look at is we're going to get you breaking down some JSON, working with words like Codable, Encodable, Decodable, and give you a real sense of how JSON parsing in Swift works. Then in order to make that call, we're going to take a look at how to make an HTTP request, a GET request, and work with things like URL, session, and task. This will teach you how to make a URL request to a backend AWS service, get that JSON response, and then ultimately parse it. Once we've got our data, we're then going to see how can we take this data and fit it into our view, in this case, a table view. I'm going to show you a really powerful abstraction, something called a view model, which takes data from the outside world and brings it into the inside world or our view. And we're going to do something with that called a view model. And then finally, in the last video, we're going to take a look at how to take this screen, which we're going to build as a standalone application, and integrate it back into the overall app. Okay, the first step in our journey is we're going to take a look at how to parse JSON. And in our case, this is the JSON request that we're going to be making to a backend AWS instance on a server. So right now I'm just browsing directly to this in my browser. I can see what the JSON request is, and this is what we're going to have to parse and somehow convert into Swift. That's going to be step one. Now, in order to do this, it's handy to know just a few basics about how JSON parsing in Swift works. So let's quickly take a look at how it really works. So in Swift, we've got these things called codables, encodables, and decodables. All Swift JSON parsing is creating a struct or a class, making it codable, and that signals into Swift that this is something that can be encoded or decoded into different transforms. In the encodable case, we can take a Swift struct, something like this, something called a modem, which has two properties, a type and a model, and we can convert that into JSON by using something called a JSON encoder and encoding the modem. Likewise, going in the opposite direction, we can decode. Here, for example, is how we take some JSON, just a string like this in Swift, and by defining a struct and making it codable with these attributes type and model, which match the keys here, we can then take that JSON and convert it into a modem object itself and store it as a result. So those are the kind of the basics of how Swift encoding and decoding works. I just want you to get familiar with those terms and those names. What I find really handy now when working with JSON is opening up a playground, taking the JSON we're going to work with, and just start playing with it. So let's create a new playground and do that now. Okay, so go ahead and fire up Xcode and let's create a new playground by going File, New, Playground. And let's just create a playground and save that onto our desk here. This can be a blank playground. I'm just going to call it JSON. And let's go ahead and save that on our desktop here. And this is going to be our play area. This is where we're going to work with our JSON and just start seeing how JSON and all this good parsing works. So if you're not familiar with Swift Playgrounds, this is a Swift Playground. This is a place where we can drop any Swift code, run it by going Shift Command Enter, and look at the output on the left-hand side here. It's a really powerful way and simple way to just play with Swift code and get a sense of how it works without having the full weight of creating a brand new project every time. So in our case, let's just start playing with some JSON and get a sense of how JSON and parsing in Swift works. So here's some JSON that we could have gotten from some backend service anywhere. This is JSON that basically describes a modem. It's got a type and a model along with some properties here. And in this case, we're going from JSON to Swift. So we're decoding. So the way to decode this in Swift is to define a struct representing this data structure, in our case modem, make it codable, which if we go Control Command click behind the scenes, we'll see is just a type alias for decodable and codable. That's all codable is. It's just a type alias for basically these two things here, which are just protocols. That's all decodable and codable are. And I'm going Control Command left arrow to step back. So basically to decode something, you just create a struct, make it codable, and then you define the attributes in here of what you're parsing. So in our case, we want to define an attribute here called type, which has to match this type here, model, which has to match this model type here. In this case, these are both strings. And then to decode that or bring that into our Swift world, we basically create a JSON decoder, pass it the type of the struct itself, and this decoder will automatically handle the rest of mapping these strings into these properties and returning us a result, which in our case is going to be our modem object. And if we go Shift Command Enter to run this, we can then see how it takes this JSON and spits out our output here. Note we didn't have to press print here. It's just enough to type whatever it is you want to see the result of. And in this case, we're just printing out the result modem along with its type and model. And that's it. That's kind of the basics of how decoding works in JSON. Okay, let's go the other way. What if we want to go from Swift to JSON? Well, we can do the same thing, just doing the opposite. Here we can create a modem programmatically. We can then create a JSON encoder, passing in the modem that we want to encode into Swift. We'll get back some data here, which we can then convert into a string by passing in the data along with an encoding type here of UTF-8. And if we run this, we'll see that we get some output here, just a string transforming our modem back into JSON. Now, JSON decoding and encoding is pretty straightforward, but sometimes you run into a case where the properties differ slightly. In other words, sometimes your Swift attributes don't always automatically perfectly line up with the JSON you're receiving. For example, we might receive some JSON for a user where it's first underscore name, but what we really want in our attribute is first name without the underscore in there. So how do we handle that? That's where these things called coding keys come in. You can define your attributes in Swift to be whatever you want them to be, but if they're a little bit different than the JSON coming in, you create these things called coding keys, and this is how you map your attribute to the one coming in that might be a little bit different in the JSON. So in this case, if we go Shift Command Enter to run, you'll see how we can take coding coming in of one form and convert it into another slightly different form in Swift. And that's how you can handle differing properties between your JSON and your Swift attributes. Now, one thing you naturally may be wondering is, Jonathan, what can we encode and what can we not encode? In other words, what types of Swift attributes do we have to work with here? And it turns out we've got a whole collection of things. We've got URLs, numbers, bools, arrays, dictionaries, nulls, even other JSON objects. So here's an example of some JSON where we have a string, we've got an int, a float, or a number. Something can be null. We can have an array of strings coming in. We can have dictionaries, and we can even have JSON embedded within our JSON. In other words, arrays within our collections here. Here's a URL, and we can convert all of those using these types. So here's a string, an int, a float. Note how the favorite here, which is null, we can represent that as a Boolean. Sorry, an optional Boolean if we know it's going to be of type bool. And again, we've got arrays, dictionaries, and these are all different things that we can create to basically parse. This one's really neat. Look at this. We have a platform in here. It's a struct within our struct. This is how we can create and model a platform within another type here, something where this entire entity is called a show. So again, we're just creating structs, defining attributes, and then decoding them. And if we run this, we should see that everything here decodes just fine. Now, one thing that's always a little bit tricky in just about every computing language is dates. How do we handle and parse dates? Well, let's take a look at some examples now. If the date comes to you in the form of milliseconds, which I don't see very often, but technically it can, then you can create a struct. In this case, I'm going to call it date record. Take your JSON where you have your date represented as milliseconds, and you can convert it basically just by passing in your date struct here and getting back a result like this of type date. Now, sometimes you'll get dates that come to you, especially from databases, that look like this. This is kind of a strange form. We can see that this is a date here, but it's got some weird stuff that I'm not really sure how to handle. This is an ISO 8601 date, and sometimes you'll get this from databases. And the way to handle this is to basically go ahead and create your struct just like you did before. So in our case, we're still using a struct Codable of type date here. That's our attribute. We're still going to use that. But here we can set a date decoding strategy on the decoder. So we've created a decoder here, and then we're telling it, hey, use this date decoding strategy for ISO 8601, and it'll go, okay. We can pass in what we want it to be converted into, the date record of ourself, pass in the data, and it too will take that and convert it properly into the real date that it represents. Now, if we're using a non-standard date, for example, if we get a nice looking date like this, but it's not something that directly translates into Swift, in that case, we can create an extension and create our own date formatter. So what we've done here is I've added an extension to date formatter where I've defined the type that I want to format here. Basically, this pattern here, YYYMMDD, matches the date we want to parse here. And by creating a date formatter, defining the date format, creating a calendar, passing in a time zone and a locale, you can return this formatter and then use it in your JSON coding down here. So just like you did before, we get the same data, create the decoder. Here we give it our custom decoding strategy, this one of type YYYMMDD. And then we can go ahead and do the date recording here, and it will convert that for us also too. Two final gotchas before I'm going to get you practicing how to do some date formatting and JSON parsing on your own. When you get JSON, it's going to come at us basically in two varieties of forms. It's basically going to be a dictionary with some attributes in it, or sometimes it can be an array. And this is a bit confusing for me when I first saw this. Take a look at this one. If the JSON comes to us and it's wrapped in these parentheses, we know we've got some attributes that we're going to have to handle. But if inside there, it's embedded within another element like this, in other words, like an array of employees. So here this could be something like a company with an array of employees. This is how an array is represented within a dictionary. So what we need to do in this case is we almost need a root construct in order to represent this entire thing called companies. So that can be a struct called company, which is codable. That represents the entire thing here. And then inside there, we're going to have an array of employees. Very, very common pattern. You see this a lot. And then employee, this is where we do everything we've been doing previously. This is where we define the attributes on how to parse an employee. First name, last name. So now when we go to decode that, we're going to pass in this company of self, which happens to have an array of employees, and Swift is smart enough to know how to take the employee decodable, use that in the company, and then decode the whole thing here, Shift Command Enter. It knows how to parse that and do that translation and spit out the values. So that's dictionary with an array. Sometimes you might just get an array back also from a JSON response. So notice here we don't have those curly brackets or those parentheses. Here we just have the array coming at us, right at the very top level element. In that case, it's exactly the same thing, only instead of passing in company, here we pass in an array of employee type dot self. That instructs Swift to take this thing. It knows it's going to be parsing an array of type employees, and that too then will know how to take that and parse it. That's just something I found a little bit confusing when I first got into Swift and JSON parsing, the difference between dictionaries and arrays. But hopefully between those two examples, that'll help make that a little bit clearer for you. Okay, now I've been doing a lot of talking, and maybe this is sinking in and maybe it isn't. But to help reinforce and get you into the game playing with some JSON parsing, get ready for your very first design challenge. Okay, let's create some space. And now this is completely optional. You don't have to do this, but I find the best way to really learn this stuff is to try it out for yourself. So there's a URL here, which is a bit of a pain to type out. I apologize. But this contains the JSON that we're actually going to be using when we parse and create that Starbucks application. So the challenge I would like to offer to those of you who are brave enough to try this out is to basically see if you can write the encoder for this. So you can download the JSON from this URL here. I've basically copied out just 3 elements of it here. And as you can see, it's just some regular JSON text. If you want, and you don't even have to use this exact JSON, but see if you can just take some JSON, any JSON you want, and see if you can go ahead and encode it. In our case here, we've got some transactions, which I'm giving you just a little bit of guidance on here. We're going to want to put in something called a history construct, which is codable. And then this transaction here is going to represent these elements here. So we're going to want to fill those in with various attributes. Take a run at it, see how you do, kind of bang your head on this a little bit, write down any questions you've got, and then come back and we'll solve and do this together. Okay, good luck. Okay, how did that go? Was it simple? Was it easy? Did you bang your head in frustration? Don't worry if it was the latter. This stuff is a little bit tricky at first, and it's not intuitive until you actually get in there, get your hands dirty, and actually start playing with it. So let's walk through this now and just see how this thing actually works. So we've got our JSON here. We know we're going to need some kind of root to represent it, and in that case, I've just arbitrarily chosen this word history. But within here, we can see that we're going to have a series of transactions, or in other words, an array of transactions. So we can basically define transactions as an array, and that's going to represent these elements here within that history. Once you've got that sorted out, then comes the fun stuff. Now we just get to fill in the transaction attributes themselves. So here, if we take a look at one of these transactions, we can see we've got an ID. So we can go ahead and create an ID attribute. It's of type int, and then we can fill in type and amount. These are both strings here, redeemed, and amount could be a number or a float, but in this case, because it's in quotes, we're just going to take it as a string. And this one's interesting here. Processed at, this is a date. But of course, we probably don't want to call it processed at in our Swift code, though we probably could. Instead, we like to call it date, and that does not match this. So what do? Well, that's where these codable key things come in. We can define date here and basically instruct Swift to say, whenever you see processed at, can you just convert that to date for us? And it'll go ahead and do it. Then, when it comes to decoding, hopefully it looks something similar to this. Here we're just going to take our string and convert it into data using the UTF format. We can then create our decoder, tell it to use that really crazy ISO 8601 date formatting decoding strategy. And then we can decode history, our root element here, from the data. And if we do that, we should get back a company with an array of a series of transactions inside, which we can then run and hopefully get back the result we're looking for, which in this case is the ID renamed 150 and the proper date. Okay, good stuff. We've just parsed our very first element of JSON into a construct we can now use in the application to help populate our view. So we're one step of the way through our journey here. We've just taken some JSON from an AWS service and parsed it into a Swift data type we can now use in the rest of our application. Come back and see in the following episodes how we now take this and build upon it by doing a real HTTP request, and then eventually take the result of that, parse it, and bring it into our view where we ultimately populate our table view. Okay, that's all for now, everyone. Thank you so much for coming. Come back and we'll continue our journey with JSON parsing. Until next time, take care. Bye-bye.